Hope you guys are having a good day so far. It's been good? Good. All right. My name is Josh Brower. Been in IT 15 plus years and InfoSec 10 plus years. Really been focused on network and endpoint detection the last few years. You can catch me on Twitter at DefensiveDepth and email josh@defensivedepth.com. So today we're going to be talking very quickly about enriching Osquery with actionable context. Anybody here familiar with Osquery? A few, maybe a half. Okay, anybody using Osquery on a regular basis? Okay, great, none. That's great. Good, so we will definitely be looking at some things that I think will be helpful for you, okay? Anybody here in my talk last year about Osquery? All right, maybe half the room. All right, so this is a new talk, so no worries, okay? It's not a duplicate. All right, so Osquery, if you're not familiar with it, it is an open source project that was first published by Facebook back in 2014. As of this summer, it now lives under the Linux Foundation, which is great for the longevity of the project. The key thing about Osquery is that it allows you to envision your system as if it's a relational database, okay? So you install it on your computer, you say select star from users, semicolon, and you get back the output. It looks like it's from a database, like you've just run a SQL query, okay? And so, excuse me. And so one of the key aspects of Osquery is that it allows you to use the query language that we already know, which is SQL. Okay, there is no proprietary language that you have to learn. It also has wide support among lots of different platforms, including the BSDs, Mac OS, Linux, and Windows. So those are really the distinctives of Osquery. Now there are two pieces to Osquery. You can run Osquery I, the interactive shell, and what that means is you install Osquery directly on your box, you open it up, and you can run your queries, and you're querying information about your local system, okay? There's also Osquery D, which is the daemon or the agent mode. This is where you push out Osquery to your endpoints. You have a management server, which there are open source management servers available, and you schedule queries to run every so often. So you say, select star from users, I want to check that every 5 minutes. And if there's a difference, if there's a change, send those logs back to me. So I schedule that query so that every 5 minutes on my servers, it checks to see if there's any new admin users. If there is, I get that log sent back to my servers, or excuse me, my log management service. And so that's what the daemon version or the agent version of Osquery is. Is that making sense so far? We're gonna be moving pretty fast since this is a lightning talk, okay? So Osquery has 230 plus tables. If you go to osquery.io/schema, you can see all the different tables that are available for you to query. These are the tables are what you can query to get all that relevant information we're talking about. There's a users table, a certificates table, all sorts of different tables that you can query to get information from. Last year, we looked at the Chrome extensions table, Chrome_extensions. This is actually a screenshot from the website. This shows you the different platforms that this table is available on. Here are the different columns you can query. So UID, name, identifier, and then here's what a query would look like. Select the user ID, name, identifier column from Chrome extensions, and this is what is returned. Okay, nicely formatted text here of user ID, all the Chrome extensions on the system, their version, and their unique identifier. Okay? Now we talked about really using Osquery in more an individual or interactive mode last year. Today we're going to briefly talk about, we've got Osquery installed on our systems across our organization, and we want to talk about Chrome extensions from that perspective. Now, if you remember, we talked last year, this is September of last year, the Mega Chrome extension was hacked, version 3394, and so we talked about how we can use Osquery to find that specific version of the extension. We simply just say, select the user ID, name, identifier from the Chrome extensions table, where the identifier is the Mega Chrome extension, and the version number is 339, and then we would get back the result if we had a compromised Chrome extension on the system. But what happens, and this is more likely the case, what happens when you've got Osquery deployed on 100 different systems on your network, and you don't really have an indicator of compromise? You don't really have this information that, hey, I'm going to go write a query that tells me this, this is what I'm looking for that's malicious or compromised. What if I'm just getting back a bunch of data about Chrome extensions? How do I know that something is malicious or has been compromised? How can I find evil even in that context? And that's what we're going to be talking about today. If we just get back this data, what can we do with this type of data? That's where I'm going to try to do a live demo, and we will see how this goes. I think it'll work. First of all, for the first prize, how many tables did I say are currently available on? Oh, man, you. All right. Your choice right here. Pick one and then leave the other one on there. First hand up. Thanks so much. Man, that was really good. I'm going to have to find a more difficult question. All right. So the scenario or the context is we have Osquery installed on our endpoints. Let's say 100 plus endpoints. We're sending data back. We've got a scheduled query every 5 minutes. Select star from Chrome extensions. We're getting differential results back. This is Kibana, which is part of the Elastic Stack, Elasticsearch Kibana Logstash. That's what I'm using in my environment, okay? And if you can see this, this is what we're currently getting back. We're getting some extension data. If I scroll down here, this is what we're already seeing. We're getting the extension description, the identifier, the name. So we're getting this information back, but the question that I have is, out of the box, this is good information, but how do we know? If we're just getting hundreds of, this kind of logged results back, how do we know that any of this is evil? Is there any other context that we can add? So glad you asked. So if we go over to, let's grab the unique identifier, which is right here, of the Chrome extension. We come over to the Chrome extension web store, okay? chrome.google.com/web store. We're just going to copy and paste that unique identifier in there. That brings up the extension we were just looking at, swag button. And there is some other extra metadata that Osquery doesn't currently bring in. We have the rating. We have the amount of users that's rated it. We have the total number of users. We also have some metadata down here on the right-hand side. When it was last updated, the size, languages. Now, what happened is, this is late last year, I got a log back from my environment that said someone had installed the Signal Private Messaging Chrome extension. Okay, if you're not familiar with Signal Private Messenger, it's a messaging solution that is supposed to be very, very secure, private, encrypted, end-to-end encryption, right? They do have a legitimate Chrome extension, but coming from this particular system and this user, I thought it was a little odd. So I looked into it more. I went actually and looked on the Chrome web store for this. It was a brand new extension, but it was labeled, Signal Private Messenger. But it only had, I think it had like 3 ratings, and it had less than 50 users, okay? And so when I went out and Googled for the actual Signal Private Messenger Chrome extension, that one had a ton of ratings, and it had over 100,000 active users. So just showing the difference just in the amount of users versus less than 50 users, I knew that there was something off on this particular extension. Come to find out, it was removed from the Chrome store within a day. It was a malicious extension. So my goal at that point was, well, that's kind of interesting. Can we get some of that extra metadata into my pipeline for logging so that maybe I can add that to my Osquery data and maybe get a bigger picture? Is that making sense? All right. So that's what I started doing. Excuse me. I started looking for a way to integrate that information. Around that time, Duo Security came out with a new app called CR Excavator, okay? Anybody here from Duo Security? Okay, too bad. I was going to give you kudos. Either way, excuse me, either way, this is a great new app. It's also got a free API. And so if we paste that identifier in there, that's going to come up with a report. Has all the metadata that we were looking for. Let me make this bigger here. All that metadata we were looking for, but it also has a specific total risk score that they have. They have their own way of identifying risk for extensions. So that's there. They have risk over time. They have permissions. They also have, if you go all the way down, potential external communication from the extension, which is kind of interesting. So this is pulled from the source of the extension. So lots of really interesting data that we can get for a Chrome extension. So it has an API, and I'm using Logstash. So I said, well, let's just go ahead and build into the Logstash pipeline. Let's hit the API, and let's get the extension metadata for each extension that we're seeing in the environment. And so that's what I started doing. If you're not familiar with Logstash pipelines, I'm not going to go into a whole lot of detail on this. The key aspect is you have an input. That's where your logs are coming from. You have a filter clause, which is what I have right here. That allows you to add and delete and mutate your data. And then finally, you have an output, and that gets output to, in my case, Elasticsearch, which then you can view with Kibana. So this is just a very simple filter clause. What we say is that if the extension, or if the name of the log is Chrome-extension-filtered, so that we know we're only going to do this on Chrome extension logs, then run HTTP. This tells us that this URL, go do a GET request on the api.crexcavator.io for the specific extension, put the response data into a new field called CE, or Chrome extension-raw, target headers put into C-headers. Then the next one is the mutate clause. All we're saying here is copy out certain fields from that API data. We're copying out the total risk rating, the web store rating, the rating users, and the users. Then we're adding a new field called report. We'll see what that looks like in just a second. And then just remove all the raw data, okay? And then output that to Elasticsearch. So every time a Chrome extension log comes through, this is going to run, and it's going to grab the metadata for that from the Duo Security API, and then put that into the log event, so that we will see something like this. So these are all the extensions that I had come through. We see the name, and then if we drill down, here are the, here's the old stuff down here. You guys should be able to see that, yep. So here's all the old information we had, right? The description, the author, the name, but then the new stuff we added, the new metadata is up here. So we have a rating. So let's add some of this to the view. Let's have total rating, the rating users, and the risk rating, and the users of the extension. So we have a nice little data table now of the Chrome extensions in our environment. And you can see that we have, in this scenario, we have the name, we have the people, or the actual rating for the extension, the amount of people who've rated it, the risk rating from Duo Security, and the total users of the extension. Now, this is okay, it's a data table, but if you're actually looking at this day in and day out, you're going to want to create some sort of a dashboard, right? You don't want to look at it in this sort of format. And so I went ahead and also generated a dashboard that took all that same information, but made it a little bit easier to read. So the first part here is we have 9 unique extensions across one endpoint, 5 high-risk extensions in our environment, and that means anything with a total risk score of greater than, I think I said 400, is a high-risk rating. And then we have those high-risk extensions over here to the far right with a little bit more information about them. If you, as an analyst, are wanting to drill down into one of these extensions, you think this one's kind of interesting, we can click the pivot link, and that's going to go ahead and bring us to the full report from Duo Security so that we can get more information about that. And then we also have the middle portion here is just a data table that allows us to slice and dice the extensions. Okay, so we can say, show me everything with a certain risk rating. How many total users? We can see that there's an outlier here, right? So we have one extension called ICE Dodo 2 with total users of 455 users, no rating because nobody has rated it so far, right? And so that would be an interesting one to look into further. Okay, so that's just, that's about all I have for the demo. We brought you all the way from, we have kind of this raw extension data that we get from Osquery. And we bring that to finding out what other context can I add to Osquery to help us understand if an extension, if I don't know that an extension is malicious, what other information can I add to that to get us to a point where we can say, I need to follow up on this or not. We looked at the Duo security API, and then we looked at the pipeline, how to bring that in, and then finally we looked at what that might look like from a dashboard perspective. Is that making sense? I went really fast, but it was lightning, right? All right, so the question is, you ready? The question is, I talked about Logstash pipelines. What are the 3 sections in a typical Logstash pipeline config? Yes? Man, good job. Yep. I have a book for you right here. Chris Sanders and Jason. Jason, can you sign this? One of the authors is here, Jason. We'll have him sign this for you. All right. Any questions or comments at this point? I'm going to pull this up real quick. So last thing I do have, we talked about Osquery. There is an Osquery class that I run, learnosquery.com. And we talk about this in a lot more depth. I actually do a demo exactly on what this looks like and bringing this data in from Logstash. Okay, but I'd be happy at this point to go in depth. All of this is available on the public repo, the Logstash pipeline. I will tweet out this deck as well as the GitHub code and everything that I talked about in today's session. I'll tweet that out later today, and you can find that on Twitter. All right. Any last questions? Yes, sir.
What have been the most difficult things for you to detect and investigate using Osquery?
What has been the most difficult? It's a pretty broad question, right? So the question is, what has been the most difficult to detect and investigate with like Osquery? I think some of the difficulties I've had with Osquery is what exactly am I trying to look for, right? Like you have access to 230 plus tables. I mean, just massive amounts of information that I can live query or I can schedule. And so what exactly am I looking for? And that actually went into my talk yesterday at Security Onion Conference where I talked about writing a playbook. And that playbook came out of my struggles with structuring detection strategies around things like Osquery and some of the other things I was working on. Really what I started doing is some people try to look at it from the perspective of you have the MITRE ATT&CK framework, you have all these techniques. Let's start building detection strategies from an Osquery perspective around all of these techniques, and you could certainly do that, and that would be one place to start. But I also just start with some really basic stuff that I see in an everyday environment, like I see domain admins setting, or people in our environment that have domain admin privileges that are using their accounts as service accounts. So I just start writing detections based on things like that known stuff that really shouldn't be happening. So I'd say my struggle has been knowing how to use, honestly, the power that all the visibility that you have. How do you know how to use that efficiently? Is that making sense? And I think as a project, I'm very involved in Osquery. As a project, I think we could do a lot better at kind of, especially new people to the project, at helping people off on the right foot of starting some of those detection strategies. So I don't know if that's where you're coming from, but any other comments, thoughts, or snide remarks? Yes, Jason. Yes. Yes. Yep. Yep. Sure. Yeah, that's a great question. So Jason's asking, and I think it's even a broader question, is that you're using a free tool, free API, Duo's CR Excavator, putting this into production. What happens when it falls over, or what happens when the person who's maintaining it leaves, right? So I have talked with the guy who created it a little bit. We chatted. I don't know the long-term support. A couple thoughts. I actually before, and I wrote this up a while ago, so it's been about a year and a half, I actually wrote something like a miniature duo excavator for me personally, because I wanted to do something like this already, but it didn't have quite the level of detail that they have. And so once theirs came out, I just got rid of my internal stuff and started using theirs. So if that went down, I would probably just pick up mine again and finish it up and maybe publish it. For me, I typically just look at that kind of stuff and say, let's run with what we got right now and be, yeah, exactly. Exactly. I don't know how much time I have. Am I done? I'm good? 2 o'clock, okay. Man, I did go lightning fast on that. That's great. Okay. Any other thoughts or comments? Yes? Sure. So more process auditing, right? So, excuse me. So from a Osquery perspective, Osquery has process auditing support built in for Linux and Mac OS, not yet for Windows, but I hear that's coming. And so we can check running processes and parent processes and things like that from a Windows perspective, but it's not fully integrated into the system yet. And so I'm not doing a ton of that at this point. But what I am doing, let me give an example. Like network connections would be another one. So all the concerns about public RDP and RDP vulnerabilities in the past year, we have a query that we run on a regular basis. Every 60 minutes that looks for port, so RDP traffic inbound from an external IP address. And the idea there is that we don't have to run network auditing, process auditing from that perspective, connection auditing, because we don't need to check every 2 seconds for network connections, because we know if there's an external RDP port open, you're just going to be hit constantly. And so we just assume we'll see connection like every 60 minutes or something like that. So from the shorter answer to your question is, I personally am not doing a whole ton of process auditing from a a Osquery perspective. That's where I would rely more on a Sysmon from a Windows perspective. Sysmon has a lot better capabilities, especially for filtering from a process auditing perspective. I would love to see more Sysmon type stuff built into Osquery so that I can just run Osquery across the entire infrastructure and not have to have Osquery plus Sysmon and things like that. And there is an extension out there that people are using that for Osquery that duplicates a lot of Sysmon type things, but it's an extension at this point. It's not an Osquery core. It's a long answer to your question. Any other thoughts or questions? Yes, sir. Yeah. So, like fleet management, what fleet managers specifically for Osquery, or? Yeah. So there are for Osquery. So if you're running if you've got Osquery as an agent or daemon installed to your organization's endpoints, you need a management server, right? Because it checks in every so often. Is there a new configuration change? What queries should I be running? There are a bunch of commercial and open source fleet managers out there. I've used both commercial and open source. From an open source perspective, I have typically used Collide Fleet from an open source perspective, and that's what I would recommend. That is also the one that we have really deeply integrated into Security Onion. The new version of Security Onion called Hybrid Hunter, you install it, you run it, you hit one command, and it installs Collide Fleet, it generates Osquery packages you need specifically for that install of Collide Fleet, and you can deploy that very simply and quickly. And so that would be my plug for Security Onion. But Collide Fleet would be the one that I would recommend unless you're completely cloud-based. There's an AWS Fleet Manager. I cannot remember it off the top of my head. It's horrible. But there is an AWS Fleet Manager that runs completely in AWS. And so that would be one to check out as well. Okay. Wes, you got anything for me? Okay, great. Okay, thank you all so much for your time. Appreciate it.